Welcome to the Interop. Today my guest is Omer Mishael. He's chief architect at Lava Network. Lava is a modular data network for scalable access to Ethereum, Cosmos, and rollups. In today's conversation, we'll discuss the market of blockchain data, RPC, API, and relayer providers, and how Lava is creating the Uber for blockchain data. We'll discuss Lava's ranking and matching engine and how that works, the different participants in the Lava network and how they are held accountable for providing reliable and accurate data, and where Lava fits in the modular stack. Before we get started, make sure to subscribe to get notified when new episodes drop every week. And remember that none of what we discuss here on the Interop is investment advice. And if you enjoyed this content, please consider staking with us. We're validating on Evmos, Quicksilver, Osmosis, and Juno. Just look for Interop in the active set. My guest, Omer Mishael, is coming up next, right here on the Interop. I'm here with Omer from Lava. Hey Omer, how's it going?
Hi, Sebastian. Good to be here.
Yeah, it's good to get you on. We've covered Lava on the podcast before. It was a couple months ago. I had Yair on the podcast and we talked about the Lava vision and the problems that Lava is solving. But now as the product is getting closer to mainnet and there's been a couple of announcements over the last couple of weeks and like some new content coming out around Lava, I thought it'd be a good time to get you guys back on and take the conversation from a different angle, because I think with you we might go a little bit more technical, a little bit more in the weeds here about the product, but also the different types of problems that it's solving for developers and just blockchains in general. But first, yeah, a little bit of background about yourself. How did you become chief architect at Lava?
Hi guys. So I'm excited to be here, and thank you, Sebastian, for having me. Those are indeed exciting times for Lava blockchain with the mainnet nearing Q1. We're progressing well with our plans, and it's going to be released really soon. Also, we're coming up with some very nice announcements, so please stay tuned for the Lava Phase 3 that's going to introduce Magma, our point system. Since those are exciting times, I'm here to help clear up what is Lava and what we're doing. I am Omer. I'm a father of one and soon two. I relocated. Thank you. I relocated to Israel to start together with Gil and Yair, the co-founders, the company. And I've been building Lava since its inception. I'm a security researcher. I have intensive background in communications and hardware development and mobile research. And I've been all over the place. I like to be versatile. And when Gil and Yair introduced me to blockchain, it was 2 months after my firstborn. And I had to struggle between not reading too much and not feeding too much bowels. I got hooked on Cosmos ecosystem. It looked so promising, the modularity of it. It was the introduction of ZK proof, the probabilistic improvements of it. And those were very exciting times for crypto back in 2021. Being introduced to it, I read about the problems of RPC and Moxie blog post that is a very respected OG in the space, and stuff didn't add up on RPC. And the amount of projects that were aiming to solve that are so few, and I didn't understand how difficult that problem is when I got into the solving it together with the co-founders. And I'm so happy I didn't understand it, because I had so many pleasant surprises along the way and so much innovation that I personally love. Together with the amazing team of the guys at Lava, we have been, crunching them one after the other, deciding on trade-offs that haven't been done in the space. And now that we feel that the product is in a great shape and can move on to the next step, we are on testnet for the last year and a half. And we are already have production customers on it. So our testnet going mainnet is kind of a weird thing because we're already incentivizing, chains with, IP RPC. We're going to talk about that a bit later. So that transition is going to be a great milestone for us. I'm really excited for it.
Yeah, it's interesting. You guys have been in testnet in production for some time because teams have been and chains have been using Lava, even though it's a testnet. So smaller validator set and like a handful of people sort of running the chain, but the product works. I mean, you guys have had a couple dozen chains live there in production for some time now. Yeah, we'll talk about the mainnet, when mainnet in a little bit, but maybe it's helpful here to go back and just refresh everyone's memory about what is Lava and what problem it's solving for blockchains, but also like developers that are building applications on blockchains, rollups, etc.
Great. I'd love to go into detail. So, with the modular narrative and the very great increase of separate stacks and solutions and new chains popping up, the need to address developers has arisen. And Lava traditionally was focused on, decentralizing RPC, understanding the pain points of the back then ecosystem, but the ecosystem has evolved. And by looking at the ecosystem and seeing the focus, it's been on monolithic chains as well. They have been focused on execution, gas prices and their cost, and permissionlessly allowing state rights, but making sure they're not wasteful. But the focus on the developers needing to interact with the blockchain and getting them to the mainstream has been always lacking and lagging behind. It's been there. You have great centralized providers that have filled that gap and have been helping developers on board, and you have a lot of new solutions popping up. But the problem in the stack today is fragmentation. So Lava aims to be the fourth layer of the modular stack and be the data access layer and help those developers that want to build tools to get to the end user interact. A lot of ecosystems are focusing on improving the existing infrastructure, more transaction per second and less checks and less test your own capabilities. And those are great technological solutions, but somebody needs to help developers access that growing space. If you have 50 great modular chains, you're gonna need 50 ways to access them. And if it's fragmented and you have different services for each, whether it's RPC and the evolvement of that by solvers and sequencers and oracles and all of that, if the barriers to move between them is high, then developers would need to choose. And the beauty of that modular narrative is that developers don't need to choose. They can build whatever, wherever. And then by doing that, Lava tries to help them do exactly that. It tries to give them a place that they can access whatever they need that's flexible enough. And how do you do that? You're doing it in a permissionless way and an open source way that anybody can access. So Lava is a blockchain that allows anybody to join and set up modular Lego block that we call a spec. And after you add it via a governance proposal, any consumer can consume it and any provider can provide it. And since it's permissionless and anybody can add it, it allows you to expand greatly, and communication is done off-chain entirely via peer-to-peer network. So Lava acts kind of like a facilitator of that communication, but is not a middleman to it. So Lava always, you go to Lava, you add your service via spec, you register your provider, and consumers can get their subscription on chain, and then they directly communicate with you. And as a provider of information, of services, of data, whether it's RPC or evolvements of that, you can move that settlement on chain and get your reward. So Lava is kind of like an interaction between off-chain and on-chain communications and the settlement of that off-chain communication, together with guarantees, and accountability. So we have been building that in order to help developers on board and get quality services and not needing to do market research on how I'm gonna access Ethereum, how I'm gonna access Cosmos Hub, how I'm gonna access Celestia, because they're gonna have a bunch of high quality providers highly available.
Great. The way I like to describe Lava is Uber for blockchain data. To me, it's really creating a marketplace for data providers, all sorts of data providers, and also services that work adjacent to blockchains like RPCs and relayers and all of this really critical infrastructure that blockchains need in order to function, that users need in order to be able to send transactions, to relay transactions across bridges. All these things that we do on a regular basis relies on third parties, and Lava is sort of solving the problem there. That this ecosystem of third parties that provide these services is highly centralized, or at least the relationships are the commercial relationships between either the applications and those service providers or the users and those service providers is highly fragmented and sometimes centralized. And so what Lava does, in my view, is it really decouples the relationship from the service and creates a marketplace where any developer, any user in the end can have access to the best service provider that they need at a specific time in a specific geography. I wonder if that's that's a good way to sort of summarize the product.
It is a great way to do it, and I love how you described it as Uber, because a lot of service providers, they already have their service and they need more approachability to data consumers, to applications, and a lot of builders, they're not even bothering to build because they're not going to be as good and as big as other providers, and then they're missing out on selling their services. So for example, if I developed a great trading platform backend that gives great statistics, and I don't mind selling it, I would love to sell it, but there's no platform for me to offer that as a service. And then developers that already make very great products of analysis and data ingestion and indexing and security modules, even in the future based on AI and protection, how are they going to get to the developers? Because developers don't have the time to find all the solutions in all the ecosystems, learn what's good, what's not good, how to interact with it. And even, for RPC, remote procedure calls that you have in a node, even they differ greatly. You could have settings in the nodes, in the service providers, in how they're serving it, and then transitioning for a Dapp that's already using one provider could be hurting production environment. And then they kind of have to develop their own code in order to do liveness checks and transition and have fallbacks. And a lot of those stuff Lava is building to solve, and we already solved so many of these problems. This is why our users are using us on testnet.
So before we get into the nitty gritty and the ranking mechanism and all of that's really interesting stuff, I'd like to maybe just put a pin in the RPCs and relayers, and what are their roles when using an app chain or using any blockchain application, and how does that currently work, right? So if you're using Osmosis, for example, you're going to be using some RPC. You're going to be using also relayers. Where are these RPCs and relayers coming from, and who's providing them, and what is your relationship to them? So maybe just sort of unpacking that so that people understand essentially the types of network participants that they're interacting with without really sort of knowing it.
Yeah. So let's go into detail how most decentralized applications work, and we can also go into detail how some enterprise grade services work. So let's say you're going on Uniswap in your browser. So Uniswap has their own account with an RPC provider, RPC being remote procedure call. It's basically anything that you send to another server to run for you and give you the response. So traditionally in the crypto space, RPC refers to raw functions being implemented in basic node function. But RPC could also be indexing services because you trigger a function with arguments on the other side and it gives you a response for it after executing code. But I'll refer RPC to the raw RPC that you get on a node. So let's say the web page of Uniswap that runs in your browser, it needs access, for example, to the exchange rate of USDC. So in order to do that, they need to fetch information from the blockchain. So Uniswap have their contract with, I think it's Infura currently, and they're fetching that information from an Infura endpoint, probably geolocated with many load balanced nodes running behind the scene. And then Infura returns that response to your web page. That response is then presented. It could be followed by many more RPC calls to verify, the block doesn't change, or verify some stuff about the RPC node itself. It could get proofs and run some verifications like light clients do when they want to check for themselves. And then, for example, you connect your wallet and then you go to your MetaMask and you want to exchange. So MetaMask has their own RPC endpoint. Usually they're using what they settled for. And then that centralized endpoint gets the transaction. The transaction gets sent to usually a different RPC provider unless you configure it manually your own wallet. And then that RPC provider gets the transaction, processes it, adds it to his mempool, and propagates it in the network until it reaches a validator that mints a block. So this is usually the flow of most Dapps. If you have, several complex web pages, so every web page you open up, it runs a bunch of RPC calls to the provider.
And just maybe just to stop you there, the reason why this exists is because no one's running their own nodes. I mean, very few people run their own nodes with which they can interact. And, I think in the early days of crypto, like 10 years ago, like a lot of people were running their own Bitcoin nodes, or at least like people I knew were running their own Bitcoin nodes. And when they would propagate a transaction, they would send that transaction to their own node. Their node was connected to the network and like all good. And then also with Ethereum, it was like pretty trivial to like run an Ethereum node. Now it's so much more complex, and there's like so many more moving parts to this that it's a lot more complex to run your own node unless you've got like a Dapps node at home or something, which is like a $2,000 investment. And so that's why like we need to use someone else's, like you're using the blockchain cloud essentially. You're using someone else's computer to issue that to submit that transaction or fetch that data from the chain. Because specialization is sort of generally what happens when things get more complex.
Yes, and also blockchains, when time moves forward, getting historical information is not something you can store on your phone. And even if you wanted to run your own node, you need infrastructure. So you would lose on accessibility. You wouldn't be able to access that from the browser. And with the modular stack and more, execution layers coming in, and each execution layer has its own rules on how to process that information, you would need so many nodes running to do a multi-chain or a modular dApp that wants to interact with many chains at once. And it's going there because the more chains you're going to have, the more flexibility, and then you're going to have more projects, fetching something from Solana and getting data availability from Celestia and reading the settlement from Ethereum. So with all of those accesses, it makes no sense that you would need to run a node or even a light client for each of them. It wouldn't fit any application, especially if you just, log into your phone, you open up the web page, and it needs to be fast. It needs to be compatible with the experience you are expecting on a Web 2 API. Otherwise, you wouldn't move to Web 3. And I am a true believer that the success of blockchain is not, only moving forward with tech. It's by increasing mainstream adoption. And the tech is very good as it is, but we need to make it easier to use, more social wallets and easier access and more visibility and more protection. So not only the tech savvy, our grandmas should use it, right? And when our grandmas could use it, then we can take it to the extreme. But currently, it's not like this in all of the tech stack. And RPC was a solution to that problem that you needed that access fast. And RPC is very Web 2-like solution until you add on top of it some elements of crypto that we have developed. And then people would look at it traditionally as a settling down for RPC. But I believe RPC is here for stay in the long term, because RPC means a service someone runs for you, meaning it's a cloud service, like taking Docker in AWS and it runs something for you. Doesn't mean you have to trust it entirely to do it, but you don't want to run it locally. When something, you want to check it for yourself, you don't run it locally. You add watchdogs on it and ways to verify it. And, you have alternatives running it for you so you can cross-reference. And those are the motives we have taken into Lava, adding statistical checks, because you don't need to check every relay in order to know that you're secure, unless you want to. And that's the flexibility we have developed, because we don't know what developers are going to need, because their needs are adapting. So the flexibility in our solution allows that.
Yeah, the way I sometimes talk about this is that we have this very decentralized blockchain, and then you have users that are interacting with those blockchains through essentially someone else's computer, and that we've scaled that so that it doesn't create bottlenecks. But the risk here is that the risk is that the access to the blockchain could be compromised if you compromise that entity, that service provider. Could be compromised from purely sort of legal perspective. So they could be subpoenaed to turn off their servers or censor transactions. It could be compromised from a regulatory perspective as well, where those nodes operating in certain jurisdictions would be coerced to censor certain types of transactions or certain addresses or things like that. And so by creating an open marketplace, I don't think that it fully solves that problem. And regulatory capture is going to come on the regulatory capture is going to happen to the industry, but at least I think it delays it, and it creates a counter pressure to overzealous regulators that might want to regulate basically RPC providers or entities that provide this sort of interaction between a user and a blockchain. If the marketplace that makes that relationship possible is itself decentralized, then it's an extra step and a more complex problem to deal with from a regulatory perspective. Let's talk about the technology here. So as a user, you're interacting with MetaMask or some wallet, right? And so typically here, MetaMask would have that existing relationship with, say, Infura or Alchemy or some RPC data provider, API provider. Let's flip that on its head and describe now what that would look like in a Lava paradigm, where you're now using Lava to choose your RPC provider, your relayer, or even your indexer in a sort of ideal world where Lava is deployed on all these apps.
Okay, amazing. So on Lava's paradigm, for any service, you're going to have a big array of providers competing for the service to provide the best service, because incentives are aligned on the Lava blockchain to the quality of service and the amount of work done. So when a user wants to use Lava, he has several ways to use it, because we have offered several implementations of our client. The first would be to go to our gateway, and our gateway is running our open source server kit behind the scenes with additional capabilities, but we've built it so people can transition securely to interacting with a lot of decentralized providers without changing their stack, because we understand existing solutions don't want to open up their code base in order to accept a new solution. So Lava created the gateway to make it easy to transition and experience that. And the gateway is fully decentralized in the sense that you can run your own. So it's a solution, it's a service that you're running, and that solution helps you participate with the Lava provider and Lava protocol seamlessly. Now, what it does is Lava, in order to be a data access layer, Lava needs to be protocol agnostic. So let's say Ethereum uses JSON RPC and Aptos uses REST and Cosmos SDK offers gRPC. Lava needs to support all of them, and that's a guiding line in our tech stack. So we need a client running the Lava code and the provider running the Lava service in order to provide the guarantees and the flexibility and the abstraction. So that client is being run on the gateway that we're offering for free, and consumers of data applications can just send relays like they're used to, like it's their own node. It would go to the gateway client. The gateway client would wrap it in the abstractions of the Lava protocol, and since it's synced on the list of providers for the gateway client, it communicates directly with providers. One of the mechanisms I'm pretty excited about in the Lava client is the selection optimizer, where it queries live and holds off data about the providers interacted with to select the best provider based on the chosen strategy. And we have developed some different strategies, like a cost strategy or a privacy strategy or a latency strategy or a freshness strategy, each having their own criteria when they're selecting providers, because the optimization happens when you have this multi-arm embedded strategy of reveal and extract for the information of providers. So what that module does, it saves up the information about the relays, about the request and the response, and the freshness of the data being the cryptographic proofs the providers attach to the responses, and then deciding what is the probability that a provider will have a specific response. So for example, I'm asking for archive data from 100 blocks ago, not archive, it's like 100 blocks ago. So the optimizer wouldn't necessarily pick the fastest provider, but rather the one that has the best availability and the best latency. So our adaptive selection mechanism implemented in the client is available through that gateway. And then the gateway interacts with the providers. The provider service can work with load balancer and many nodes behind it, or one provider service per node. And that provider dewraps the communication. It takes it to a language the node understands, being JSON RPC, for example, or a WebSocket subscription, and then sends it to the node. The node processes the request and responds. The provider service gets the response, attaches the necessary headers for accountability that the provider signs off, because every request on Lava is cryptographically signed and therefore accountable, and sends it back. This back and forth between the consumer and the provider happens in something we call sessions, and sessions are aggregated in order to minimize the impact on the blockchain when you want to settle, because we are building for scale. So if every relay created a bigger proof in order to get rewards on chain, it wouldn't scale well. And we have seen that in other decentralized solution where the amount of relays increases the proofs. So on Lava, the proofs aren't, the size isn't increased, and each relay is aggregated to the same size of proof. It's not even, log off, or it's just the same size of proof all the time. And then the providers can claim rewards on it. Another solution we offer, except for, the enterprise grade, many consumer solution, we offer an SDK. It's mostly aimed for web pages, because they have the element of popping up, needing to sync really fast, get their service, their 100 relays, present the web page, maybe do some stuff in the background later to refresh it. But the goal is different than having many users with a lot of memory. So it would be much more light. The SDK is very small in size, and we have already integrated with so many libraries, Web3, VM, WAGMI, Ethers, and whatnot. And it works together with those libraries, so you don't have to change your code. You just need to import the snippet that sets Lava as the layer behind these very flexible frameworks, and you're using them as you're used to. So that's something nice that you can add on top when you're developing.
So that's on the application layer. So let's say like you're building a front end, like Uniswap, say front end, you'd integrate the Lava SDK into your, say, React application or your Web3 JS, and that kind of replaces or will do that matching and provide the right RPC endpoint or relayer or data provider to the user.
Yes, and I'm really proud of that innovation because imagine that every request needs a cryptographic proof, but a web page is a compromised environment. You couldn't store your private key on a web page because somebody could take a console or attach a debugger and read it. So how do you provide cryptographic proofs to relays to prove that you're really the consumer? And then provider needs to get paid for it, so you need to make sure it's not abusable. So we had an innovation there about a system we call badges, where the front end goes to a badge server, requests for a temporary badge in order to use on behalf with a generated on the spot private key. And then the badge together with a private key can cryptographically sign a certain amount of requests. So there's no risk of abuse because that the badge server protects his master key, and then the secondary key of the badge can be used with the provider. The provider can still claim on-chain on these relays, but it cannot fake that badge because it's signed by the key of the subscription that created it.
Okay.
So
so the matching and like all that operation happens when exactly, and is the matching happening? This is where I've not yet fully understood like the order of things. As a user, I connect to like Osmosis. I've got my Kepler wallet. When I go to the website, that the website's providing data. So the website has indexers with whom it works that's providing data to the front end. Potentially, like they could have integrated Lava, and then Lava is providing the best indexer for the user. But then when it comes to relaying the transaction and finding the best RPC endpoint, let's say there's like an RPC endpoint that, like down the road, and it has like all on the other ranking metrics, it's also ranking high, right? So naturally, you're going to want to take that one because it's geographically close and it has good liveness, etc. Is that matching happening directly with the user pinging the Lava blockchain, and the Lava blockchain is sending back that data provider, or is it the application that's doing that from a backend server? And I guess my what I'm trying to understand here is like, what is the level of peer-to-peerness that is happening, and how are you is Lava eliminating the need for the user to interact with a third-party server, in this case like Osmosis or Uniswap, to do that matching for them? Do you understand my question?
Okay. Yeah, I understand clearly, and I'm glad you asked it because we have two mechanisms in place. The first being a mechanism to take the very big list of providers and narrow it down. Why do we need that? We need that in order to do a best mix and match of consumers and providers. And if you're not narrowing it down, any consumer can interact with many providers at once and they don't know about each other. And then you have to limit the rate that the user can do so it doesn't clog your system with many clients. So that pairing mechanism, it's happening on chain, but it's not something that you need to do often. What happens is you have a deterministic function that gets set. It's a pseudo random function because it's deterministic based on a seed, but the seed depends on the blocks, so it's randomized. And then you have this function. Nobody calculates it. Why? Because everybody have the arguments and they can calculate it offline. So you can run an RPC to your node. Nobody else knows you did it and knows what your address is. You run it and you get your list of providers. The providers aren't running it yet. So you do that, you run it locally. For that, you would need the rule set of the blockchain. So you would either need a node for it, or you need somebody to run that for you, okay? And then you get that narrower list of providers. Now, how does the SDK execute that without trusting a third party or a single point of trust? So this is where our decentralized bootstrap mechanism comes into place. It's a solution that's inspired from seed nodes, where you have this initial list of, trust. Why I call it trust? Because it's not really trust, it's like an accountability list. So you have a list of providers that are accountable. The way you generate it is either you run it once a month, with your own node, you set it up, you run it, you write it in your backend, and then you bootstrap from there. And that list is accountable for a long period of time, let's say 2 months. And once a month, you refresh it. So any provider on that list is accountable. And if he responds in a fraudulent response that is cryptographically signed, like every relay on Lava, you can report him on chain. So the SDK starts with that list of providers. It queries them all at the same time for that initial bootstrap. And they give you the list of providers from a different chain you need. So for example, Uniswap needs an Ethereum list of providers. So you would go to that static list of Lava providers for the Lava pairing, and you get that smaller list of Ethereum providers. Once you have that smaller list of Ethereum providers, we have the second mechanism in place, which is the optimizer that probes them live to see what is the best fit for your specific web page. Because, for example, Uniswap uses Lava, and they get a very big subscription, and they get like 24 providers at the same time. Your web page would need all 24 at the same time. So it would probe the best ones, it would pick the closest ones with the highest quality, and then you would take those providers and you would use them from your web page. So different wallets or different dApps would use a different set of providers, all in the same, pairing for the Uniswap account. And we offer configurability. You could set geolocations in the pairing. The pairing mechanism, I will go into detail if it's fitting. How that selection of providers is done on chain. But once you have that selection, you do the sub selection live based on the service, based on the load, and based on the latency from that specific node.
Yeah, let's get into it.
Okay, so the pairing mechanism is taking several arguments into account. The first being the stake of the provider. Understanding that stake gives you more trust, and then therefore you bring more users to that provider. Also, it's a mechanism for providers to fine-tune demand. So for example, you need more demand, you increase your stake, you increase your incentive for Lava ecosystem to work, and then you're getting more consumers. And having that stake mechanism in place is not sufficient, because providers can have different qualities. So for example, I could be a provider that's offering archive or offering a specific add-on for debug. So we have filters in place for the specific needs of a consumer. So our RPC consumers, the applications, they can configure the preference in their subscription object on chain and then affect the pairing accordingly. So I could provide a configuration for give me a mix of debug and archive and regular providers, and then the pairing mechanism would create what we call slots for archive, slots for debug, and slots for providers, and then it would generate a list of eligible providers for that slot. And then eligible providers are going to be weighted together with on-chain quality of service of excellence that we're saving from replies of consumers from the same group. That's our clustering mechanism. Maybe I can go into that as well. And then you have the score calculated based on the stake, based on geolocation fit, based on that quality of service of excellence, and those filters to get a weighted choice that is pseudo randomly calculated based on the hash of the block, on the consumer address, on the provider. And then you have that selection repeatedly fitting in providers to the slots to provide the best match with providers.
That's a really complex mechanism. So how does this clustering work then? And like, is this create more efficiency when selecting the data provider?
Yes. Our clustering mechanism basically counts on the fact that different consumers are going to have different needs. So, for example, if I'm a consumer and I care about latency, I could create, define the strategy of ranking based on latency alone. And if I'm a consumer and I have the balance strategy, I would rank providers based on availability and sync and latency together, being, averaged together. And then every relay from a consumer to a provider, because it's wrapped in the Lava protocol wrapper, is going to contain the current quality of service from that consumer to that provider. When providers ask for rewards on chain, they're actually reporting themselves and other providers from the responses of the consumers. And they cannot be tampered with because everything is cryptographically signed by the client themselves. So we were thinking of several approaches, one being a fisherman, but a fisherman is less effective and you actually have to fund it. And what could be better than clients reporting live on their own service? And we have addressed, incentives and game theoretic models in order to make it not profitable to lie. So the clustering mechanism is one such mechanism. So as a client, you're ranking providers, and then this rank affects how you're gonna get that provider in the future. What it also means that you're gonna be clustered by a k-means with other clients having the same effect. So for example, if you are a very big enterprise consumer and you got in your pairing a very small node, a very small provider, and it cannot, serve the amount of volume that you need, you're gonna give him a low availability score, and then you will get him less often. Other enterprise grade consumers would report the same. You would be clustered closely together in a cluster. And then that cluster affects the way providers are chosen for that cluster. So the way we're protecting our customers is that if an attacker comes and provides false reports, if they're outside the standard deviation of the cluster, he would move to a different cluster. And there's gonna be live feedback from the providers themselves about the quality of the service that consumers saw, and that picture of cluster is gonna be adapted accordingly.
Now, when it comes to the participants that are making this matching happen, who are the different participants of the Lava chain? I mean, obviously we have the validators, like Lava is a Cosmos chain, and there are validators that secure the chain, participate in governance, etc. But there's other participants. Can you describe each participant and what is their role in making
in the ecosystem
Lava function?
Yeah, sure, would love that. So the validators are maintaining the security of the chain, but besides them, you have two more important roles for the protocol. The first being the data providers. They are registering on chain to provide data, and they're staking their tokens in order to incentivize them to provide honest service. And there are the consumers that are purchasing subscriptions on chain via transaction and getting access to that data. So providers would need to run a service and a node for the chain that they're supporting, or the service they're indexing, or the AI that they're running. And the consumers, they have the single subscription. After it was purchased, they can start sending relays to all of the providers. And the fourth role in the ecosystem are contributors. Contributors are people that can either create new specifications and add them, or encourage existing and maintain existing specifications. They are participating in a reward based on their contribution. And they're actually the ones that are adding more services. So it's like an NFT that you mint. So the creator gets, his share of the reward. So if you want to create a new service, you set it up on Lava, you're gonna get your share of rewards as long as it works and it's being used. And this is how you scale it with incentivizing innovation and creating services that actually match what developers and applications need.
Right. And so just to clarify here, like the consumers are the end users that are interacting with Lava directly, but the those who are paying the service providers on behalf of the consumers are the projects. So the consumer isn't paying a service provider directly via a transaction fee. That's abstracted away so that they just have to use it. They can just use the service. There's probably like a blockchain or a foundation or some other entity, the product that is paying Lava to facilitate this relationship.
Well, long term, that's exactly the vision. But what we currently see, and I'm pretty proud of that collaboration, is the ones that are funding that are actually ecosystems. So we have several partnerships that we think are going very well with Near, FMOS, and Axelar. And those ecosystems, together with our partnership, are actually purchasing those subscriptions for the consumers to use. And in a project we call IPRPC, Incentivized Public RPC, the benefits of that approach is that ecosystem that traditionally have to deal with centralized providers and doing a mix and match of several providers or closing a deal as a foundation with those providers, they didn't know what they're paying for. I mean, they can get feedback from developers or they run their own testing services, but it's actually very hard for them to know if the customers are happy and what they're getting. So our very big customers, being ecosystems, are joining us, and they're taking their rewards and they're distributing them back to the community of their providers. And we have our faithful providers, they're seeing a new initiatives and they're joining their forces and setting up new nodes in the ecosystem in order to provide service for it, being incentivized in the native token of the ecosystem, which is very exciting because this is how during testnet we could actually make it production ready. Then where these ecosystems actually give back to the providers and the providers give back to developers, and developers can interact and experience and ask for more services. Everything works together much better. Ecosystem have a peace of mind about the load and about the quality of service because it's all settled on chain on the Lava blockchain. It's public information. Everybody can see how much the ecosystem cares about developers. Providers can check their profitability, and if the ecosystem wants to scale up the support, for example, God bless, we're gonna have a bull run soon, and suddenly Near are gonna launch their data availability service, and it goes well, and everybody want to scale up using Near. How they're gonna scale up? So now they have to go and negotiate with their centralized provider, and the centralized provider would struggle to ramp up their service because it's temporary. The easy alternative that is offered via IPRPC, and I think it's what attracts them, is that they can increase the rewards. Regular Joes can set up nodes, having lower barriers of entry to provide high quality service, because the services we provide already have a lot of tech that regular people aren't able to deploy. So it was mostly saved for VC-backed centralized companies, and we took that time to develop during the bear market, and we provided these tools to the community. And we have some very nice innovations in terms of performance that make it for that anybody that deploys a node can join and provide service, high quality service with that. And our docs help them improve over time, and the feedback from the system is going to help them improve over time. And while they're at it, they're not disturbing users because we just pick the best ones, and they're incentivized to do it. So it's a very nice ecosystem of symbiosis.
I think there's one thing that there's one benefit that is maybe not obvious from using Lava, is that applications using Lava get all of their data in one place. They get all of their data providers in one place. So if you're an application that interacts with many different chains, say in your front end, or you have like relays that send messages to and from different chains, using Lava across your entire stack just allows you to get access to everything, because Lava already integrates with like more than 30 chains. I keep losing track of count because you're adding new ones all the time. But yeah, basically it's like you get a one-stop shop for all of your data needs, and not have to have like relationships with different data providers, etc., and like different types of data providers.
Exactly. And also on top of it, you can own what is offered on Lava. Having the specs being a modular stack and anybody can add a spec, let's say as a developer, you need something that's not supported on Lava. Then you can set it up as a proposal. You can discuss in the community to see, that the providers and after it's passed and introduced on Lava permissionlessly, it start being served immediately, and you don't need to change your tech stack. You can set up one SDK instance on TypeScript web page, and you get access to all of these sites at once. And if you look at the networking, you're gonna see you're pinging Near providers and Ethereum providers and Lava providers and Berachain providers, and it's all existing in the same SDK. So the flexibility of building multi-chain is amazing. And the widgets that you can build on top of it to have pre-made front-end libraries is gonna be amazing. And within the vision of Lava, people wanting to go multi-chain will have it very conveniently in their single on-chain subscription. Currently, everything is for free. And while ecosystems keep, IP RPC live, it's gonna stay that way for those ecosystems, unless you're, scaling very well, which is good news for applications, and then you need more. And then this tool is aiming to help you access the increasing modular stack. And without this tool, you would have so much fragmentation, and then developers would have to choose where they're building and what they're building on, which is something that is going to prevent Web3 from scaling.
Cool. So I'd like to maybe take a step back here a little bit and talk about the modular stack. And like so far, I think we've been talking about Lava in the context of the monolithic chain and app chain paradigm, or at least that's how I've been framing it in my mind. Now, as the ecosystem moves to a layer 2 roll-up model, and we have thousands of applications leveraging underlying security, underlying data layers, data availability layers, how will Lava help support the growth of the ecosystem?
Looking at the three existing modular stacks, you could see that the access for developers is kind of missing from the paradigm. And Lava aims to be that fourth layer of developer access. And how we do that is we're gonna aim to fix fragmentation. So let's say we have Eclipse building an SVM machine on top of a Celestia data availability layer and Ethereum settlement, and then suddenly how do developers access that? So do they need to now ask some centralized provider to support it, and then having up and coming ecosystems, they need a way to convince that it's worth it, that it's financial, and waiting for them to add it. Or even worse, let's say they mention having 10,000 app chains popping up. It would be so easy to set up an app chain, but if it's very difficult to develop on it because the rule set of the app chain is not readily available for applications to process, then that could actually be the bottleneck for scaling up. And with a paradigm where Lava simplifies that, Lava supports these app chains very quickly and easily. The modular specs, the beauty of it is that they can inherit existing solutions. So let's say you created an SVM, you don't need to create a new spec. You just say, hey, this is an SVM. Let me inherit from an SVM spec, define the new verifications that you need for your own solution, being it, for example, a different chain ID even. It could be the only difference in terms of data access. And then providers can serve it. So the thing is, specs are so flexible in the way that what you can bring into your existing solution without having a lot of work, that it scales very well with new chains. So, for example, Berachain had their testnet very successful initially, and they had RPC problems. And Gil, our CTO, told me, "Hey, can we support Berachain?" Until immediately, and it took me 1 hour to deploy it on our testnet, and it took me longer, to get people that have the binary to actually join it. So the Lava stack actually supported it super fast, and that's how easy it is to add existing solutions. And Lava was built to support all of those solutions, supporting so many different API interfaces, being it gRPC, REST, URI, Tendermint, JSON RPC, WebSocket, you name it, GraphQL queries. All of those are abstracted by our clients, meaning that you can, just patch in your API set. You define, the rule set of the APIs, stuff like the compute units that you're offering for each API. So settlement is fair in terms of compensation and incentives to the load that you're performing. And then that's it. You're ready to go. You attract your providers. If you have a faithful community that are already running it, so they can access immediately developers. If you want to do an IPRPC endeavor, or you want, developers are profitable enough to pay for it, they have the flexibility to do so.
So if we have light clients, let's say in the future where you're interacting with a chain or with an application via a light client on your phone, or light clients are integrated in browsers, and you only interact with the chain directly or mostly directly, let's think big here. What's the role of Lava then in that case?
Yeah, I would love to answer that because it's something that you have to really think about in order to process. Light clients are an amazing solution for a certain set of requirements. They can help you verify yourself, which is amazing. It is amazing if you don't have to go lightweight. And even with super lightweight light clients, you still need, in order to verify that you're doing more processing. So light clients are lighter than regular nodes, but they're not lighter than somebody else processing for you. And when those queries are super heavy or computational is complex, light client cannot replace that. What it can do is it can delegate it. So a lot of light clients are actually RPC. What they're doing is they're asking a node to run, to give them a proof and the data, because they don't have it, right? They can verify, but they're not tracking the chain and doing calculations. So actually light clients are actually RPC clients. They're asking the chain. Now, why do people treat light clients differently than RPC? Because light clients usually do it on the peer-to-peer network. So usually when you have an RPC, you have a dedicated node for RPC and the peer-to-peer network that you're running with regular nodes. And you do not differentiate usually on the peer-to-peer light clients and regular nodes that you need in order to sync on the network. But in a future where you have so many light clients, the load of computation is going to fall on nodes. So these nodes are going to either altruistically or with a service those thousands of light clients querying, give me the balance and give me a proof for it and give me an ETH call contract, or give me a specific account's permissions. And then the nodes need to supply that. And if they're not supplying that, there's no answer for the light client. So in a future where Lava exists, actually Lava facilitates the communication of light clients and their dedicated nodes. So imagine you could get a subpar experience of light clients via the peer-to-peer network, but you could actually use Lava with incentivized nodes to provide you that information quickly and with high scale and guarantees. So you could actually make your light clients work faster by joining Lava network. So light clients and Lava aren't competing. Lava aims to create light clients environment where it's monetized correctly and incentivized correctly in order to support it. And then an ecosystem could say, hey, I really believe in light clients and I want 100,000 light clients and only 5 nodes. And I want these nodes to scale really well and provide that service. Yeah, go ahead. You do an IPRPC endeavor for light client support, and light clients can connect through Lava and those nodes are monetized. And I saw that Nick White talked about the problem of increasing the amount of light nodes, having it not monetized. So Lava actually uses collateral and on-chain feedback and accountability to attach incentives to providing services. That's what we are so good at. We are good at people permissionlessly coming, serving information, having guarantees on that information and repercussions, because if you're signing off on a wrong response, everybody can see it, and we have an on-chain resolution mechanism that can get you jailed or slashed, and then that mechanism guarantees your integrity, because depending on the client, some clients would configure their clients only to wait for a consensus of a lot of relays, but a statistical client that says, hey, most of the time I'm happy with statistically checking, which is what most checks are nowadays. That's the standard for crypto, because you don't want to check everything because that's redundant. And then those checks are catching fraudulent providers. So providers are incentivized to behave honestly. They have their stake in place. And then they can you can actually monetize providing service, whether it's for a web page, for a light client, or for a enterprise grade company that requires millions of RPC calls.
So as we wrap up here, I wanted to maybe talk a little bit more about the roadmap. Currently, the product is in testnet, so people can actually go to Lava network.xyz and start using Lava integrated in their application. It's still in testnet, but you can use it in production. But yeah, what's the road to mainnet, and when airdrop, if any? I always ask that question, even though people can usually not answer, but I like to ask it anyway. At least I've done my diligence.
I'm not wearing the foundation hat, so I cannot reply to that.
Yeah.
But we will announce a foundation really soon. We're on track for launching Q1 mainnet this year, 2024. We have progressed greatly with IPRPC endeavors, and we have increased demand for it. We have some very exciting announcements regarding IPRPC with some stuff that are coming for sure, yet haven't been announced. And the roadmap for the close period is focusing on mainnet and focusing scalability and the deliverance of the great product we have been building during increased demand that we are expecting in the next year. And besides that, we're scaling up our data access services, having some great partnerships such as Subsquid for indexing services, and we have been in talks with some centralized providers joining in, providing their services. I cannot name them until they want to officially go live, but they will be providing their services on Lava as well. So Lava is gonna, moving forward, it's gonna, in the close year, is gonna expand and add more services. And in the long term, I envision Lava helping sequencers offer their services in a decentralized manner. And you could have solvers providing intent services and decentralized Oracle. So the future for providing any API in a centric place for aggregation, permissionlessly accessible with a very varying tech stack, I think it's gonna be the way for developers to build. That would be the go place for a developer that wants to build on blockchain to go to, because it's gonna be well documented with a lively community that is dedicated to making developers' lives easier. And service providers are gonna come and offer their services there first because they can focus on tech instead of hype. And they would be chosen because their quality of service is better, or they're giving the flexibility of the service to their consumers rather than having a brand or specific stuff that are missing where the other stuff are subpar, but the users are locked in because they need that.
Excellent. Well, Omer, thanks so much for coming on and spending time with me dissecting Lava and getting to understand all the technical aspects here, because I think that's one of the most interesting things about Lava is just like how technically complex it is, but also what a great product it is for developers to get better access to data, and I think unfragment this data offering that we have in crypto. that I think is a big problem for developers to build great applications that people want to use. So thanks again for
Thank
coming on.
you very much for having me and taking the time to explore the complexity of solving that problem in Web3.
Thank you.